We talked of exponential laws and we applied them, okay, or on the just simple expressions. Now we need to apply those very same laws, exponential laws, on equations, meaning exponential equations now, because we do have them, exponential equations. We apply them this way. If you have to solve for x looking at this, 2 in brackets half 2 x plus 1 is equal to 16. Exponents here, exponents and equation. So it's up to you. Divide 16 by 2, and then there are so many ways to do it. What I did, I divided 16 by 2, then I got 8. From there, I should manipulate on 8 because my variable is the exponent. I cannot get rid of that exponent until I manipulate here. So what do we do? Okay, you manipulate this. Okay, 8 as 2 cubed, of course. But what I did here, I started by writing half, expressing half as 2 to negative 1. Okay, what is important, guys, is my right hand side. Okay, this one is easy, straightforward. And then what do you have? You have negative, you're multiplying here. And again, watch out, guys, when you multiply here, most of you just multiply negative 1 by x. You leave this guy. This is one thing, a unit, x plus 1. Then you must multiply here, as I said, the sharing part, multiplied here and there as well. Then you get that. So my word was here, as you can see now, 2 cubed. That is my big worry. So what do? The bases are the same. Then we drop the bases. It's what we're saying. Base on the left is the same base on the right. Only if you have 2, 2, or 3, 3, or x, x, as long as you're talking of the same thing. Drop it, concentrate on the exponents. Negative x minus 1 equals 3. Now solve for x. Easy. Back to simple equations, linear equations. Solve for x. Let's see. Your x is going to be negative 4. Guys, I'm not going to talk of this use. Easy stuff. You know it. How to simplify. Now we can look at another example. It looks complicated, but it's not. 9 to x minus 2 times 27 to x equals 3. Now let's have a look. Should we express as the same base? If I were you guys with this sum, I would express 9 and 27 to the same base. Let's see. Yes, it's what I did. 3 squared, I expressed 9 as prime base and I expressed 27 as prime base, which is 3 there. So I multiplied here. If you look at the 2x minus 4 comes from 2 times x and 2 times negative 4. This, the same story here. You multiply that. Now what do you know? You can combine this, put them together under the first law at the exponents. Should we do that? Yes. 2x plus 3x is 5x, and with minus 4. We added the exponents. What do we do now? I just talked of this. Same thing. 3, 3. It means drop the bases because they're the same. Concentrate on the exponents. Then 5x minus 4 equals 1. Easy stuff. Easy stuff. Straight to the answer. Straight to the answer now, guys. X equals 1 from here. Cool. Now we can look at another one whereby you have 2 to 1 minus x. Okay. Same base, and surely you're not gonna combine this with that. There is no law of subtraction here. We don't have specific law. You rather do this 2. This 2 you can because you have multiplication, but not jumping to that. You cannot jump to that. Okay. We have equal to 0. What I did before I did that law, I just took the whole thing to the right hand side because it's 0. Oh, you can divide by. There are so many ways to deal with this. Okay, let's look at my simple way here. I make this invisible one, you see. There is invisible one there. I made it visible now. And add this. It's not times. Look, times is here. Then the rule says add the exponents. Why? The bases are the same. Go. 1 plus 1 is 2 minus x. Drop the bases. Why? They're same here. Same basis. Drop the basis. You go 4 equals 2 minus x. Straight to the answer now. X equals negative 2. Cool. I would like to get to another example here. which will be my last example under the equations. So we have x to half equals 8. So let's look at this. X to half equals 8. And you try to figure this out. Guys, this time the exponent is your base. The exponent is numerical value. So how do we do this? If you want, still you can make the top the same and you drop the top, you take the basis. That law can reverse, but I know that is hard for that. Let's look at the simple way. So what I'm gonna do here, you just multiply by the inverse of this, the reverse of this, reciprocal of half. Then you have 2 over 1. It's what you should do. Why? The exponent is a number, it's a numerical value. Do that. Multiply, always multiply by its reciprocal. But if the exponent is x, a variable, now we have a problem. We should always try to manipulate the right to make the same basis. Okay, now we have this equals a squared. And then this will now cancel. This will now cancel. And then multiply to x is equal to 64. Guys, I've shown you how to apply those exponential laws on the equations, hoping that you will do so with your exams, with your formal tests, cycle tests in your school. Until we meet again, guys, cheers.